Hello, this is Farhan Shakil from the Republic 2.0. And in the last part of this video, we have talked about the May 2025 Unit 1 physics paper of International Edexcel. In the last video, we solved all these multiple choices, and today we'll do the mechanics structure problems from this paper. And if you talk about question number 11, we've got this question number 11. A resultant force of 4800 Newton acts on a boat. The acceleration of the boat is 0.31. We need to calculate the weight. So this question is quite easy. So, according to the second law of Newton, the resultant forces acting on an object is equal to mass times acceleration. For the weight, we need to calculate the mass. So the mass from this equation would be equal to the resultant forces divided by the acceleration. The resultant forces acting on this object are 4800 divided by the acceleration is 0.31. So when you're going to divide them up, you would be having something like 15,500 kilograms. That is going to be the mass. After calculating the mass, you can easily get the weight as well because the weight is m times g. So W comes out to be 15,500 times 9.81. So when you're going to times them up, the final answer that you would be having is 152,000 newtons. So that is how we're going to calculate the weight for this question. And now we've got this question number 11. A person rides a bicycle along the path shown. He starts from here and end over here. At the end of the path, the magnitude of displacement from the start is less than the distance traveled by the person. It is less than the distance traveled by the person. Describe why the displacement is less than the distance traveled by the person. So everybody knows that, displacement has to be less than the distance. This is a two-marker question, so we need to at least write down 2 points. So first of all, you need to mention that whenever you talk about displacement, the body covers displacement in a straight line, right? Displacement is always in straight line, right? Displacement is always covered in the straight line. But on the other hand, whenever you're talking about distance, it is just the length of the path between 2 points. Displacement is the length of path between 2 points. What does that mean? That if you're talking about the distance, you need to cover this path, right? And if you're talking about the displacement, you just need to cover this straight path. So, just use your common sense. So displacement has to be less than the distance, right? Because of this observation. So now, after this thing, we have got something like this thing. You've got the velocity time graph for the part of a bicycle ride is shown, something like this. And it is a VT graph. We need to calculate the maximum acceleration. So first of all, remember body is covering acceleration in this part from O to A. Body has some acceleration from A to B as well. And body has some sort of deceleration from B to C. And by just using your common sense, the greatest magnitude of the gradient is from O to A, right? So whenever you're talking about the acceleration, whenever you're talking about the maximum acceleration, you need to take the acceleration of this part. And the rest of the thing you already know. If you want to calculate the acceleration, it has to be the gradient of VT curve. It has to be the gradient of VT curve. So that is how we're going to talk about the acceleration. And whenever you want to calculate the acceleration, it has to be change in y upon change in x. So you can see that if you're talking about this point, the y coordinate has to be something like in between 6 and 4, that has to be 5. And the y coordinate over here sounds like something like 1.8, if I'm not wrong, right? So, you've got y2 and y1, and that has to be 5 minus 1.8 divided by x2 minus x1. So if you look over here, the x2 has to be something like this is going to be 15, then this is going to be 16. So you have got 16 x2 and x1 is going to be something like behind 5, that has to be 4. So by just solving this thing down, you'll have the maximum acceleration of an object, and that has to be 0.267 meters per second square. So that is how you're going to calculate the maximum acceleration. The main point is that whether you'll be able to determine that in which part out of OA, AB, and BC, the body would be having a maximum acceleration. Now you have got this question number 30. In a game of basketball, points are scored by throwing the ball so that it falls through the hoop. The rule states that the distance between the hoop and the flow, this horizontal distance between the hoop and the floor, which is going to be this distance, right? The vertical distance, D, should be 3 meters. The basketball player throws the ball so that it falls through the hoop as shown. When the ball was thrown from a height of 1.7 meters, so the initial height was already given, and that is 1.7, right? So you've already got this height, 1.7. The initial vertical component of the velocity is 5.1 meters per second square. The final vertical component is 2.1 meters per second square, and deduce whether the d was 3 or something else. So, we just need to work these things down. So to calculate the total distance from the above height to the hoop, I'm going to use the third equation of motion, where v square is equal to s square. V square is equals to u square plus 2a or g times s. Since we're looking for the distance, so it has to be something like 2gs is equals to v square minus u square. And s comes out to be v square minus u square divided by 2 times g. Now, what was the final velocity? Since that velocity would have been downward, so I'm going to take it as a negative velocity. And the final answer that I could have from here has to be something like minus 2.1 square minus 5.1 square divided by, since the ball is moving up, the gravitational acceleration has to be negative 9.81. And when you're going to simplify this down, the distance that I would be having is going to be 1.1 meter. So total height of the hoop above the flow has to be 1.7, which was the initial height, plus 1.1, which comes out to be 2.8. And since 2.8 is not equal to 3, so the claim is not right, right? We just needed to deduce that whether the d would be 3 or not. And that is how we're going to deduce that d is going to be 3. Now we have got this question number 14. You have applied the brakes in the car reduces the kinetic energy. In an electric car, some of this energy is transferred to the battery of the car. So what does that mean? That the input has to be the change in the energy, and the output has to be the energy transfer to the battery. So you've got this you've got this mass, you've got this speed, and you can calculate the kinetic energy, and it's going to apply some brakes. The vertical displacement of the car is 0.76, right? And the energy stored in the battery is going to be 45 kilojoules. So that has to be input from the given data. And how would you calculate the output? First of all you need to do is to calculate the kinetic energy, and that has to be 1 by 2 mv square. So half times 1800 times 14 square. And when you're just going to simplify this down, after simplifying it down, you must be having something like 176,000 joules. And whenever you're talking about the gravitational potential energy, it has to be mgh. Whenever you're talking about the mass is 1800 times 9.81, and the vertical distance they covered was 0.76. You're going to times them up, and you would be having something like 13,400 joules. So if you want to calculate the efficiency, it has to be input, which was output. This is going to be the output because that is the energy transferred to the battery. So 45 times 10 raised to the power of 3 divided by the difference, the change in the energies. And that has to be 176,000 minus 13,400. So the efficiency comes out to be, 45 times 10 raised to the power of 3 divided by whatever this gives you, 176,000 minus 13400. And when you're going to divide them up, you would be having an efficiency of about 0.27. So that is how we can easily calculate the efficiency. Now, we've got this force extension curve, and we need to determine the increase in the elastic strain energy in the brick as the force increases from 85 to 140. So what does that mean? First of all, point out the 85. So 85 must be, somewhere. I'm just taking a hand guess. 85 must be somewhere over here. So the area covered under this part of the triangle, that has to be the force extension curve. And the other thing is 140, right? So you've got 140 somewhere over here. And if you're going to calculate the total area up till 140, that has to be this one. But we're just looking for this area, right? So we're going to calculate the total area for the triangle of 140 Newton. And then we're going to take it away from the triangle of 85 Newtons, right? And if you're talking about the compression, compression is just being a bit misplaced. Remember that, I've taken the data from another paper. The compression over here has to be something like 97. And if you talk about the compression over here has to be something like 60, right? So you can just simply calculate the change in the energy. Yeah, the energy stored between 85 and that thing. So the elastic potential energy has to be something like 1 by 2. First of all, 140, the extension is 97.5. It was nanometers, so 10 raised to the power minus 9. This is the total work done up till 140. You need to take it away from 1 by 2 times. The other thing is 85 times 60 times 10 raised to the power of negative 9. So you just need to, subtract them up, and you'll get the final kinetic energy that comes out like 4.28 times 10 raised to the power of negative 6 joules, right? That is how you talk about the elastic potential energy stored between those 2 points. Remember that that is not a triangle. So you need to calculate the area under the smaller triangle, area under the bigger triangle, then subtract them up, and then you'll get the area in between them. The last question of this part, the bricks undergo the elastic deformation. What is meant by the elastic deformation? Such deformation in which a body can regain its original shape. Such deformation in which body can regain its original shape after removal of force, right? Even whenever you're going to remove the forces, the body will, you know, regain its original shape. So, I've done all the questions related to mechanics in Unit 1. In the next video, I'll come back to you guys with all the question on materials. Thank you very much.